Example 6 on viscous flow in pipe stacks under laminar flow. In the sirens shown below, the drug has a density of 900 kilograms per cubic meter and a viscosity of 0.002 pascal second. The flow through the needle is 0.4 milliliter per second. Neglecting the head lost in the larger cylinder, determine the following. The velocity at point B in meters per second, the Reynolds number for the flow in the needle, and the steady force F required to produce the given flow. So for the first question, velocity at B is 4q over pi diameters of B square. The discharge is 0.4 milliliter per second in cubic meter. That's 0.4 divided by 1000 square, or 0.4 times 10 to the negative 6 cubic meter per second. Then divided by pi, diameter at B is 0.25 mm over 1000 to make it meter quantity square. So the velocity at B is 8.149 meters per second. Then the Reynolds number for the flow in the needle. Reynolds number is diameter, mean velocity, density over viscosity. So substitute 0.25 over 1000 times 8.149 times 900 over 0.002. So the Reynolds number at B is 917, which is less than 2000. Therefore, the flow in the needle is laminar. Take note that the velocity at A is negligible even if you compute it by continuity equation, so it is negligible. That's why the head loss in the larger cylinder is negligible, as stated here. So we take note of that. Then HF in the needle is friction factor L over D times velocity head in the needle. So friction factor for laminar flow is 64 over Reynolds number. Length is 0.02 meter divided by diameter 0.25 over 1000. Then 8.149 square over 19.62. So the head loss in the needle is equal to 18.9 meters, which is also the head loss from A to B. So writing energy equation between points A and B, we can compute the pressure at A. Then this force here is pressure at A times area at A. So velocity head at A, which is negligible, plus pressure head plus elevation head at A0, velocity head at B plus pressure head at B is 0, that's exposed already. And G sub B is also 0 plus head loss from A to B, which is this head loss in the needle. So 0 plus pressure at A over 0.9 times 9810. Let's make the pressure at A in Pascal. 0.9 is a specific gravity, 900 over 1000. Then specific weight of water. 0, elevation head at A, velocity head at B, pressure head at B 0, that's exposed. Elevation head at B is also 0. And head loss from A to B is the head loss in the needle alone, 18.9. Solving for P sub A is 196,751 pascals. So F is pressure at A, area at A. So F is 196,751 pi. Diameter is, radius is 5 mm in meter, 0.005 meter square. So F is 15.45 newtons. So that's it for this problem.